welcome back to this episode. In today's lecture, we are going to look at artificial intelligence. We are going to try to establish a basic definition of what intelligence is, and then we'll transition to looking at what artificial intelligence seeks to achieve. And we're also going to talk about the different types of artificial intelligence, and I'm going to try to convince you not to be scared of AI, because people have funny ideas that humans might end up creating some AI agent that will destroy the world and all that. And I think we are very, very far from that. But I'm going to illustrate to you on this board, try to explain to you what artificial intelligence is, and then you can judge for yourself. Maybe after the end of this course, based on what you've learned, you can judge for yourself and then know whether we are anywhere close to being able to create robots or agents that can destroy the world, or we are very far away from there, or we should rather focus on the promises, the good aspects of artificial intelligence, and then honing all our skills and energy on gleaning what can be achieved from there rather than being scared. Okay, so before we start, I want us to take a look at what this word here means: intelligence. Okay, and if you Google this or you look up intelligence in a dictionary, I promise you 2 words are going to come up in a lot of definitions that you will get. One is the ability to acquire knowledge, and the other is the ability to apply knowledge. Okay, so that is intelligence. Intelligence is defined as the ability to acquire and apply knowledge. Okay, and so artificial intelligence is actually an intersection of these 3 fields, that is statistics, computer science, and mathematics. So AI, or artificial intelligence, sits at the intersection of these 3 fields: mathematics, computer science, and statistics, and it seeks to give the computer the ability to be able to acquire knowledge and to be able to apply knowledge. And that is all that AI seeks to achieve. It's an intersection of statistics. Once we start the practical demonstrations, you see that all that these AI deep learning models are doing is to learn patterns from data using statistics, mathematics, and computer science, because of course you'll be writing code, mathematics and statistics, because there are approaches from these fields that you apply to be able to learn. Well, I'll explain what it means to learn once we get practical in this course. But for now, I want you to understand that AI sits at the intersection of math, statistics, and computer science. And what it seeks to do is to be able to let computers have these 2 capabilities. So 1 is to acquire, and 2 is to apply. So once we start the practical aspect of this course, you see that we will do all these 2 phases. The first phase is what we call training, where we expose our model to large data sets, and then we give it a lot of time, depending on the capabilities of your computer. You give it lots of time for it to acquire all the patterns that exist in the data. And the second phase, which is what everybody knows out there, is the application aspect of it. So if I train the model on how to identify shoes, the training process is going to involve me exposing my model to lots and lots of pictures of different types of shoes in different environments with different backgrounds, different types of noise in the background. And then once the training is done, once the acquisition state is completed, I can begin to apply it. And the application stage is where I will show my model a never seen image of some shoe, and I expect my model to be able to tell me with a high level of accuracy that this is a shoe, and let's say this pen, if I show it to the model should be able to tell me that this is not a shoe. In that case, I'm not expecting my model to be able to tell me that this is a pen. All I want it to tell me is that this is not a shoe. And the reason it is able to do that is because it has acquired some representation of what it means to be a shoe. And when you show it something it has never seen before, it is not able to tell you what it is. And so that brings us to these two types of artificial intelligence. The first one is artificial narrow intelligence, which is known as ANI. And then we have artificial general intelligence, which is known as AGI. And they seek to do different things. People are mostly speaking of artificial general intelligence, which is very far away, because what artificial general intelligence seeks to achieve is to be able to train a computer or be able to train an AI model that is able to do everything. Okay, it is quite very ambitious, because as humans we don't even understand how the brain works now. And so for us to be able to, or for us to attempt to give that capabilities to a computer, it requires us first and foremost to understand how our brain works, which nobody as at now really understand what even a single neuron does in totality. There are ideas, people know how neurons are working, and in fact they somehow loosely, and I need you to note the word loosely, influence how deep neural network architectures work, but they don't have a tight coupling with how the brain works, even though it influences it loosely. So, like I said, artificial general intelligence is an attempt to give general intelligence, just as human beings are able to do. We are intelligent, we're able to learn quickly, we're able to distinguish what we know from what we don't know. Once we identify something that is completely new, we're able to link it to something that is familiar to us, and then come up with an estimate of what we think it is. It is not so when it comes to artificial intelligence models. Once you train them on some particular data set, they are very good at working on identifying or making predictions based on data sets that or examples that are similar to the training examples that you use to train the model. But artificial narrow intelligence, which is what you have been hearing about, all the deep learning hype, is all about artificial narrow intelligence, where you focus on training a model that does one and only one thing very, very well. So if I train a model to be able to distinguish, let's say, goats from sheep, all I know is that all that model knows is that it knows how to do it very well. It knows how to distinguish goats from sheep. If I train a model to be able to identify overspeeding cars from stationary cars, that model becomes exceptionally good, depending on how you train it, of course, but it becomes exceptionally good at distinguishing overspeeding cars from stationary cars. But apart from the ability to distinguish between overspeeding and stationary cars, it is not able to know, it doesn't know any other thing in its environment. Okay, so all the hype about deep learning is centered around artificial narrow intelligence, where we are focusing on training models that are able to solve one problem or a set of problems very, very well, instead of attempting to give general intelligence like human beings or animals are able to do. So in this course, our focus is going to be on artificial narrow intelligence, and henceforth, as somebody who is interested in learning AI, I need you to understand that most of the time when people are talking about breakthroughs in AI and modern advancement in AI, it is all centered around artificial narrow intelligence. There are models that are exceptionally good because, of course, the computer is a giant calculator. That is all the computer is. It's a giant calculator that is able to perform billions of instructions per second, much, much faster than what human beings are able to do. But it is not able to perform perceptual tasks as easily as human beings are able to do. So what deep network techniques or AI techniques are helping us to achieve is to be able to train computers to do things that are within the domain of artificial narrow intelligence. And artificial general intelligence, the one that seeks to give computers general human-like intelligence, is something that is very, very far away, because it requires that we understand exactly how the human brain works before we will be able to train computers to do that. For example, if I didn't know these things, I will not be able to teach you what I'm teaching you. In the same way, until we understand exactly what intelligence is, what it means to be able to learn, what it means to be generally intelligent, what is happening in our brain, how is the brain learning, how is the brain functioning, it is almost an overshoot to attempt to give to a computer the capabilities that you do not already possess. So as somebody who is interested in artificial intelligence, and I mean the practical aspect of it, I think it is important for you to always make the distinction that there's a difference between artificial narrow intelligence and artificial general intelligence. And all the hype, all the breakthroughs, all the achievements in AI so far is centered around artificial narrow intelligence. So thank you once again for watching. And in the next episode, I'm going to try to establish the link between artificial intelligence, machine learning, and then deep learning. So thanks for watching, and I'll see you in the next video.